in our last video for this section, I just want to get a little bit more practice with the quotient rule. And again, just to remind you that the quotient rule is just a way to take the derivative, and the derivative still tells us the rate of change. So in our last example here, we have a drug that is injected into a patient's bloodstream through her right arm. The drug concentration in milligrams per cubic centimeter in the bloodstream of the left arm, t hours after the injection, is given by C of t equals 0.14 t divided by t squared plus 1. The first part of this question, all I want to do is find the derivative c prime of t. So I look at our function right here. This is a rational function. We are definitely going to need to use the quotient rule here. So for our, c prime of t, for our quotient rule, it says low, so here we're going to start with t squared plus 1. D high, derivative of our numerator. Here we should just have 0.14 minus high, so here we're going to have 0.14t. D low, derivative of our denominator. Here we should have 2t. Square the bottom, t squared plus 1 quantity squared, and away we go. So again, I'm just focused on simplifying this numerator. Here I can distribute that 0.14. So we'll have 0.14 t squared plus 0.14 minus, if I multiply those two, I should have 0.28 t squared, all divided by t squared plus 1 quantity squared. Again, don't worry about the denominator. We don't need to simplify that. In our numerator, we can combine some like terms, so we're going to have 0.14 minus 0.14 t squared, all divided by t squared plus 1 quantity squared. So here is our derivative, the first part of our problem, c prime of t. We've got that. We used our quotient rule. Part B, the second part of our problem here, I would like to find c prime of 0.5 and c prime of 0.5, and then interpret those results. So let's start with c of 0.5. Let's go look at our function. Let me see if I can copy this. Oh, I'll just remember it. C of t equals 0.14 t divided by t squared plus 1. Let me just double check I got that right. Yes, that looks good. So c of 0.5, well, I'm just going to take 0.5 and I'm going to plug it into my function here. C of 0.5 equals 0.14 times 0.5, all divided by 0.5 squared plus 1. Be careful if you're going to try and type all this in your calculator in one step. Make sure that denominator there is in parentheses. But let's see what we get here. Divided by 0.5 squared plus 1, close my parentheses. I have 0.056 at the end of this problem. So I also want to be able to talk about what does this mean within the context of my problem. So t, first of all, t, that was 0.5. If we scroll back up and look at our problem, t, first of all, represented the number of hours after the injection. So 0.5, that would be a half an hour after the injection. What does c of t represent? This represents the drug concentration in milligrams per cubic centimeter in the bloodstream of the left arm. So if I wanted to talk about what this means, we said t was 0.5, so here 0.5 hours, or you could say half an hour after the injection. The drug concentration in the left arm is simply the number that we found, this 0.056. Let me double check my units here. Milligrams per cubic centimeter. So we'll say milligrams per cubic centimeter. So here, this isn't, since we're working with the original function, this isn't a statement of change. Nothing is increasing or decreasing here. It's just, this is what the drug concentration is at this point in time. If I want a statement of change, I'm going to look at the derivative. So here we're going to look at C prime of 0.5. So here I'm going to take that and plug that 0.5 into my derivative, which we said there, 0.14 minus 0.14 times 0.5 squared. All of that divided by 0.5 squared plus 1 quantity squared. Again, just be careful as you're typing this into your calculator. It's very easy to make a mistake. So 0.14 minus 0.14 times 0.5 squared divided by 0.5 squared plus 1 quantity squared. I ended up with 0.0672. So if I want to talk about what this number means, first of all, t hasn't changed. T is still 0.5, so a half an hour after the injection. So if I want to talk about what this number means, half an hour or 0.5 hours after the injection. Here we're talking about the derivative of C. So C told us the drug concentration. So the drug concentration in the left arm. Here, now we're talking about a statement of change since we're working with the derivative. So I'm going to look at my C prime of 0.5. I'm going to look at the sign in particular. Is it positive or is it negative? Well, in this case, it's positive. So that means my drug concentration is increasing by that 0.0672. Let's see, our units were milligrams per cubic centimeter. And we also want to make sure we say, how often is it increasing by this amount? Is it increasing by this amount every day, every year, every minute, every second? We have to know. We have to have a unit of time here. And for that, we're just going to look at what was our unit of time here. We said T represented hours. So we're going to say it's increasing by 0.0672 milligrams per cubic centimeters. We'll say per hour or each hour. So again, just to remember, we've got the product rule, we've got the quotient rule, but they're just new methods to find the derivative, and the interpretation of the derivative has not changed. We can still think about it and interpret it exactly the same way that we have since the beginning of this course.